You're listening to DTFHN for June 17th, 2026. I'm your dirt, under the fingernails host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where pedantry is a love language. Today's got roots in the ground and fists in the air. Strap in, we're going deep. Let me make the case against caring about this. 744 billion parameters, 40 billion active, burning through 43,000 output tokens per task. That's almost double what GLM 5.1 used. The model got smarter by thinking longer, not by thinking better. Token efficiency went backwards. Cost per task nearly doubled from 25 cents to 46 cents. A cynic would say ZAI just cranked the compute dial and called it progress. Now, let me show you why that argument collapses. GLM 5.2 scores 1524 on GDP Val AAV2. That's the agentic benchmark. Real-world task completion, not pattern matching on multiple-choice questions. At 1524, it is effectively level with GPT 5.5 on extended high reasoning. In MIT licensed model, weights available on day 1, deployable on 8 different third-party providers, matching a proprietary model that costs multiples more and whose architecture you will never see. The efficiency critique is real but misses the forest. Yes, 43,000 tokens per task is heavy, but the intelligence gains are not uniform padding. Scientific reasoning on CritPT jumped 16 points. Trafta gained 12. Scicode gained 7 to reach 50%. Terminal Bench, which tests actual terminal-based problem solving, climbed 16 points to 78%. These are capability thresholds, not marginal improvements. The model crossed into territories where it becomes genuinely useful for scientific work. And the architecture tells the story. 744 billion total parameters with only 40 billion active means this is a mixture of experts model. Same size as its predecessor. Same inference footprint, but 11 points higher on the intelligence index. The context window went from 200,000 to 1 million tokens. The per-token pricing stayed flat. ZAI improved the routing, the training, the data. Not the parameter count. MIT license, 1 million token context, available today on Deep Infra, Fireworks, Nebius, and 5 other providers. The hallucination rate dropped from 29.4% to 28.1%, while accuracy climbed. These are small numbers that matter enormously when you're building systems that need to be trustworthy. The comments are split. Some users report it doesn't feel as capable as the benchmarks suggest. Others confirm strong real-world performance. That gap between benchmark and subjective experience is worth watching. But the trajectory is the signal. 6 months ago, the best open weights models trailed proprietary frontier by 15 to 20 points on composite indices. GLM 5.2 is within striking distance. The cost of openness used to be capability. That tax is shrinking toward zero. And once it hits zero, the only thing closed models have left is lock-in. Which was always the point. We talked about intelligence emerging in the open. Now let's watch it emerge from single cells. Story 2. High-res Neural Cellular Automata. There's a moment in watchmaking. Bear with me. Where a master craftsperson realizes the movement doesn't need more gears. It needs better finishing on the gears it has. The mechanism stays simple. The output becomes exquisite. That's exactly what's happening in this Show HN project. And the elegance deserves attention. Neural Cellular Automata have been one of the more beautiful corners of AI research for years now. Simple cells, local rules, emergent complexity, digital life growing patterns, the way crystals form or embryos differentiate. The problem has always been resolution. If you want a detailed image, you need a dense grid of cells. And dense grids mean expensive computation. The standard approach is brute force. More cells, more compute, more memory. Scale the lattice until the output looks good enough. This project takes the watchmaker's approach instead. The NCA itself runs on a coarse mesh. Relatively few cells, lightweight updates, the kind of computation you could run on modest hardware. But then comes the clever part. A second network, what the authors call a local pattern producing network, sits between those coarse cells and the final pixels. It's a small MLP. A shared lightweight neural network. That takes the interpolated state between neighboring cells and a local coordinate and produces high-resolution output at any point you sample. Color, surface normals, whatever you need. The coarse automaton handles the dynamics. The LPPN handles the detail. And they train together, end to end, each learning to complement the other. Think about why this matters architecturally. The cellular automaton keeps its beautiful property. Local communication, emergent FAHO, self-organization. Without paying the resolution tax, you're not choosing between interesting dynamics and sharp output anymore. The movement and the finishing are separate concerns, jointly optimized. The interactive demo on the page makes this tangible. You can see the coarse cell state. Blocky minimal. And then watch the LPPN transform them into detailed, smooth output. It's the same information, rendered at two different levels of abstraction. The gap between them is where the craft lives. What I genuinely admire here is the refusal to solve the problem by throwing scale at it. This is someone who looked at the computational bottleneck and asked not, how do I afford more cells, but how do I need fewer? That instinct. Compression over expansion, architecture over brute force, is how the most lasting technical contributions tend to work. The tools exist to scale things up. The art is knowing when to stay small. 3 stories in, and we're already stacking wins. Let's keep it going. GrapheneOS just landed on Android 17. What does it actually take to keep a phone secure? Not the marketing version, not the checkbox compliance version. The real answer. Because most people assume their phone maker handles it. And most phone makers do, right up until they decide your device is too old to bother with. GrapheneOS just ported to Android 17 on the same day Google officially released it. Day 0, not a week later, not after a scramble, not with a partial build missing half the device support. They had it running on the Pixel 6a, 7, 7a, 8, 10a, 10, and 10 Pro Fold, before most people even knew Android 17 was out. Full device support across the entire supported lineup, with public code landing the same day. Pull this thread for a second. This is a volunteer-driven open-source project maintaining a hardened fork of an operating system built by one of the largest corporations on Earth, and they're shipping same-day ports. The engineering discipline required to do that is genuinely remarkable. You're not just rebasing patches. You're maintaining a comprehensive security architecture on top of a moving target, where every upstream change could break your hardening, your sandboxing, your verified boot chain. And they do it with a fraction of the resources Google has. The comments tell a story worth hearing. People running GrapheneOS for months, for years. One person bought a Pixel 10 and never even booted the stock OS. A 20-year iPhone user reconsidering. And then there's the person pointing out that Pixel phones aren't sold worldwide. Which means this level of security is effectively region-locked. That's a real tension. The most accessible hardened mobile OS in existence still depends on hardware. from a single manufacturer with limited global distribution. The upcoming Motorola support can't come soon enough. This is bootstrapism at its most concrete. A small team publishing everything, building in the open, giving anyone with a supported device the ability to run a phone that respects them. The code is there, the builds are reproducible, the threat model is documented. Nobody's asking you to trust a brand. They're asking you to verify. What gets me is the tempo. Android 17 drops, GrapheneOS is already there. That's not just good engineering. That's a team that treats your security like it matters today, not whenever the next quarterly update cycle rolls around. We talked about running things yourself earlier. Well, local AI models? That whole space just got really genuinely good. In 1995, Linux couldn't print. I mean, technically it could print if you had the right printer and the right driver, and you'd compiled the right kernel module, and you didn't mind spending your Saturday reading man pages written by someone who clearly resented the existence of other humans. The refrain from the Windows crowd was always the same. It's not ready. And they were right, until one day they weren't. And by then, the entire internet was running on it. Local models just had their printing moment. Let me break down what actually changed. The constraint was never, can a model run on consumer hardware? The constraint was, can a model run on consumer hardware? The constraint was, can a model run on consumer hardware and produce output you'd actually use instead of just deleting? Those are very different engineering problems. The first one got solved 2 years ago. The second one got solved about 6 weeks ago. Vicky Boykes has been running local models on a 2022 M2 Mac, 64 gigs of RAM, nothing exotic, and she's now doing agentic coding loops at roughly 75% the accuracy of frontier models. She's refactoring Python, writing unit tests, bootstrapping recommendation systems. On her laptop, with Gemma 4, the 12 billion parameter quantized version, not some data center monster. Strip away the marketing from both sides. The cloud providers want you to believe local will always lag. The local enthusiasts want you to believe parity is here. The truth is more interesting than either pitch. What's happening is that architectural innovation, mixture of experts, quantization-aware training, is making the gap collapse faster than anyone's pricing models anticipated. Gemma 4 is asking a question the frontier labs would prefer you didn't think about. What if the right trade-offs at small scale get you 80% of the way there for zero marginal cost? The comments are revealing. Someone claims Claude Sonnet is a downgrade from local Quinn. Someone else says local models are still painful. Both are telling the truth about their own experience, which is exactly the point. The threshold is personal, the hardware is personal, and critically, the data stays personal. This is the Linux trajectory, not a single dramatic victory, but a slow, irreversible compounding, where every month the excuse to stay dependent on someone else's server gets a little thinner. The tools exist. The weights are open. A 3-year-old laptop is the data center now. Run it locally. See what happens. So you're running your own models. But where do you find the independent voices writing about all this? I built a link aggregator once. Nothing fancy, just an internal tool for a team that wanted to surface interesting work from across a dozen internal wikis. The hardest part wasn't the ranking algorithm or the vote system. It was curation. Deciding what belonged. Every aggregator eventually faces the same architectural choice. Do you let the fire hose run, or do you build walls? Bubbles.town chose a specific wall. 5,000 independent personal blogs. No corporate publications. No Medium posts optimized for the algorithm. No Substacks gaming paid conversion funnels. Just people writing on domains. They control, ranked by votes and freshness. This matters more than it sounds like it should. In 1993, the web had a discovery problem. You could publish anything, but finding it required knowing someone who knew someone. NCSA's What's New page was literally a hand-curated list of interesting websites, updated by humans at the University of Illinois. It was arguably the first front page of the Internet. Then Yahoo came along and tried to organize everything into categories. Then Google came along and made categories irrelevant with PageRank. Each generation solved discovery by adding more automation, more scale, more algorithmic mediation. And each generation made the individual voice harder to find. Bubbles is walking that timeline backward on purpose. 5,000 blogs is a deliberately small number. The Mastodon login requirement, which some commenters dislike, is a deliberate friction point that filters for a specific kind of user. These aren't accidents. They're architectural decisions about who the system serves. One commenter said it feels refreshing compared to doom-scrolling social media. That's not a feature request. That's a diagnosis. The dominant platforms optimize for engagement, which means optimize for emotional reaction, which means optimize for content that makes you feel something fast and forget it faster. A front page of personal blogs optimized for votes and freshness is optimizing for something else entirely. Call it curiosity. Call it tape. The independent blog is the oldest form of open publishing on the web. No platform owns your words. No algorithm decides your reach. No terms of service can memory hole your archive. But every blog on its own domain is a tiny sovereign server, and 5,000 of them with a shared front page is a federation that actually works. The tools exist. The blogs exist. Someone just built the lobby. Now let's talk about what happens when the institution stops serving the people building the future. 20 people. That's the number we're sitting with. Not the billion-dollar price tag. Not the 9 years of development. Not even the X-ray mirrors made of single crystal silicon, which is a phrase beautiful enough to deserve its own paragraph. 20 people took buyout packages from NASA, and a space telescope designed to study the first black holes in the universe collapsed behind them. One of those 20 was the engineer designing the heaters that keep the mirror at constant temperature. Another was the astrophysicist who invented the mirror technology itself. The team that remained inherited, and I'm quoting here, their PowerPoints. They were trying to reverse engineer a billion-dollar instrument from slide deck. Follow the logic all the way down. The stated principle behind DOGE is efficiency. Government should run lean. Eliminate waste. The telescope wasn't canceled. That would be a decision, and decisions require accountability. Instead, a fifth of NASA's workforce took buyouts. Engineers got reassigned to projects aligned with a budget that Congress hadn't even voted on yet. Then a government shutdown ate 6 weeks. Then the team got 2 weeks to hit a budget target they'd been structurally prevented from meeting for months. The mission died of starvation, while everyone involved could truthfully say they never killed it. Here's what's worth naming. 40% of all basic research funding in the United States comes from the federal government. 40% flowing through one gate, one budget, one administration's priorities. If you built a software system with that architecture, every engineer in the room would call it what it is. A catastrophic dependency on a single upstream provider with no SLA and no failover. The researchers who lost this telescope aren't the ones who pay the real cost. Reynolds has tenure. He'll be fine. The cost is the graduate students who won't get hired, the postdocs who'll leave the field, the institutional knowledge walking out the door in exchange for a severance check. The X-ray astronomy expertise that took decades to build doesn't come back when the political winds shift. You can't pip install a generation of scientists. The telescope was called AXIS. The acronym stood for Advanced X-ray Imaging Satellite. It would have looked back in time to study how the universe assembled itself. Instead, it became a case study in how a country disassembles its own future. Not with a vote, not with a debate, but with a buyout package and a shutdown and a 2-week deadline that everyone involved knew was impossible. The tools to study the origin of everything, defunded by people who can't see past the next quarter. We talked earlier about building tools that matter. Here's a story about someone who found a tool and made spectacularly poor life choices with it. 47,000 IIS servers. That's roughly how many Shodan will return on any given Tuesday, sitting on the open internet, broadcasting their version numbers in plain text response headers. A researcher published a walkthrough this week for systematically dismantling them during bug bounty engagements. And the methodology reads less like hacking and more like filling out a form. Send an HTTP 1.0 request. Read the location header. The server hands you its internal IP address, its hostname. Sometimes the name of the exchange box running behind it. No exploit required. It just tells you the question worth asking is not whether IIS is insecure. It's why, after 25 years of patches and hardening guides and compliance frameworks, the default configuration of one of the world's most deployed web servers still leaks internal network topology to anyone who asks politely. The walkthrough is methodical. Google Dorks to find indexed ASP.NET pages, Shodan queries filtered by SSL certificate, Nuclei A templates to automate the known misconfigurations. Then the manual work probing virtual host bindings, exploiting legacy DOS 8.3 filing conventions that IIS still honors, because backward compatibility is sacred in Redmond. Every technique described is publicly documented. Every tool referenced is open source. The knowledge has been available for years. The servers remain misconfigured anyway. One commenter noted they deliberately front their honeypots with the IIS landing page because, quote, it attracts black hat jagoffs, and nothing makes them happier than wasting hours of someone's time. That's telling. The IIS splash screen has become a signal not of a functioning web server, but of either negligence or a trap. When your product's default state is indistinguishable from bait, something has gone structurally wrong. The entire guide exists because security researchers share their methodology openly. Every scanner, every template, every technique published freely so defenders can find their own gaps before someone else does. This is how security actually improves. Not through closed audits sold at enterprise rates, but through people putting their knowledge where others can reach it. Meanwhile, the 8.3 file name bug dates to an operating system released in 1981. It is 2026, and servers are still resolving tilde character paths because nobody at Microsoft will break backward compatibility with MS-DOS. That single architectural decision, compatibility over safety, has generated more bug bounty payouts than most researchers can count. The tools to find these servers are free. The knowledge to test them is public. The only thing keeping them vulnerable is the decision to leave the defaults alone. Here's something genuinely wild. Beneath your feet right now. Fungi have built a communication network spanning over 100 quadrillion kilometers. 10 meters! That's how much fungal network fits in a single teaspoon of soil, not visible to the eye, not something you'd ever think about while walking across a field. But there it is. a root-level internet that predates the Cambrian explosion by a comfortable margin. A team from the Society for the Protection of Underground Networks just published the first global map of arbuscular mycorrhiza fungi, and the numbers are staggering. 110 quadrillion kilometers of hyphal networks threading through the planet's soils. That's roughly 10.5 light-years of biological infrastructure. You could reach Alpha Centauri and keep going, all of it built by organisms that have been running the same protocol for 475 million years. Carbon from plants in exchange for water and nutrients from soil. A handshake older than trees. The engineering here deserves real admiration. These fungi solved distributed resource allocation before multicellular life figured out how to crawl onto land. Every hyphal thread is a micron-scale pipe moving phosphorus, nitrogen, and water to wherever the network needs it. And critically, they're pulling carbon down into the soil in the process. Not as a side effect, but as the core transaction. The plant pays in carbon. The fungus banks it underground. Now run this forward. The study found the cropland fungal density is 47% lower than wild ecosystems. Tilling literally shreds the network. Heavy fertilizer use short-circuits the symbiosis. Why would a plant trade carbon for nutrients when you're dumping synthetic nitrogen on it for free? But that fertilizer has to come from somewhere. Usually natural gas, and the carbon that would have been pulled into soil stays in the atmosphere instead. The beautiful thing about this research is the data set itself. 16,000 soil cores, machine learning models, and the explicit goal of giving governments benchmarks for what healthy underground ecosystems look like. Open data for an invisible commons. The researchers are presenting findings at the Desertification Conference in Mongolia this August. Grasslands came back as the densest networks. The Everglades, the South Sudanese wetlands, prairies worldwide, many of them poorly protected. The infrastructure we can't see is the infrastructure we keep forgetting to defend. But now there's a map. And a map changes what's possible. 9 stories in, and we've gone from underground fungi to outer space to literal dirt. I love this show. Story 9. Anthropic published a startup playbook this week. It's polished, it's thorough, and it makes a genuinely compelling case. Use Claude at every stage of your company. Idea validation, MVP architecture, launch automation, scaling operations. The framework is smart. The founder stories are real. And if you're building a company in 2026 and you're not using AI tools extensively, you're probably leaving value on the table. That's the steel man. And it's strong. Now let's talk about what the playbook doesn't say. Every architecture diagram in this guide, every workflow, every agentic automation. It runs through one company's API, one set of rate limits, one pricing page, one terms of service document that can change on a Tuesday afternoon. The playbook tells you to build your nervous system on top of infrastructure you don't control and can't inspect. This is where engineering due diligence matters more than marketing copy. When you architect a startup around a proprietary model, you're not just choosing a tool, you're choosing a landlord. And the question every founder should ask, the question this playbook never raises, is what happens when the objective function changes, when the pricing tier shifts, when the model gets deprecated, when your most critical workflow depends on a system whose weights you cannot examine, whose behavior you cannot reproduce, and whose continued existence is a business decision made by someone else's board. One commenter nailed it. This is a shovels play, and selling shovels is a fine business. But the playbook frames dependency as strategy, And that deserves scrutiny. The craft here is genuinely impressive. The section on preventing technical debt in AI-generated code bases is useful regardless of which tools you use. The measurement framework for distinguishing real traction from hype is the kind of thing founders actually need. Credit where it's earned. There's substance in this document. But the most important startup advice for 2026 is the advice no vendor will ever give you. Run your critical path on open models. Use open weight alternatives where they exist. Treat any proprietary API as a convenience layer, not a foundation. Build so that if any single provider disappears tomorrow, your company survives. The tools are extraordinary right now. Just make sure you can switch which tools you're holding. And on the theme of tools you already have, but might not know about, here's a genuinely delightful one. Someone in the comments corrected the author. Quote, Bash cannot speak HTTP. You are speaking HTTP yourself. And technically, pedantically, beautifully. They're right. Bash doesn't know what HTTP is. It just opens a socket and lets you shout into it. The fact that shouting the right sequence of characters at port 80 gets you a web page back is your problem, not the shells. Here's the setup. You're debugging a container. Minimal image, stripped to nothing. No curl, no wget, no busybox, no package manager. You need to hit a health endpoint on another container across a Docker network, and you discover that Bash has this trick. DAV, CATP, host, port. That opens a raw TCP socket through a path that doesn't actually exist on disk. It's a phantom device. Bash intercepts the redirection before the kernel ever sees it and quietly does the connect call for you. Now let me argue the other side for a moment. This is terrible. You're handwriting HTTP headers with printf. You need to remember the carriage return line feed endings. Forget the connection close header and cat hangs forever, waiting on a keep alive socket that will never close. There's no TLS, no redirect handling, no chunked transfer decoding. It's not even POSIX. Dash and Zush won't do it. You could call this a foot gun dressed as a feature. But that argument collapses the moment you're actually inside that stripped container at 2 in the morning. The tool you have beats the tool you don't have. Every time. The Plan 9 folks in the comments pointed out they had real synthetic network file seedings decades ago. Mount another machine's net directory, and you've got an instant VPN. The Unix world took the idea and made it a parlor trick hidden behind a compile flag. Typical. This is builder culture at its most fundamental. The socket is there, the protocol is just text, the rest is ceremony. This has been your daily tech feed for Hacker News for June 17, 2026. This podcast is entirely AI generated. Scripts by Claude Sonnet 4.7. Voiced by Claude Sonnet 4.7. Voiced by Claude Sonnet SRAT. Not affiliated with Hacker News or Y Combinator. Now go build something that's yours. We'll see you back here tomorrow.